What's up, amigos? Today with the aerodynamics of the FIFA World Cup trophy. So I was inspired by the Vince Lombardi trophy that I did a couple weeks ago, and now we have the aerodynamics of the FIFA World Cup trophy. And it's pretty interesting. So the globe on top, it redirects the flow a lot down, so it's producing a little bit of lift, it looks like. Around the actual globe itself and then the entire trophy, the flow does accelerate a lot. You can see that it goes up to like 27 meters per second and higher. And we've seen at the bottom bit in a few other simulations where when you neck something down, so it has a wider cross section up and below, then you get the flow going sort of channeling into this section, and then behind it you get the roll up where the flow underneath is further away. It rolls up into that little wake there. So that's interesting. And now we have the Y plane going through the trophy, and it's colored in the U velocity again. And it's really interesting how at the bottom bit, how I was just talking about that necking down bit, that's the point that has the greatest wake. So you can see up above, even though the actual trophy itself has a much greater cross-sectional area, the wake is not nearly as extreme as down below, where it extends far greater, and it's also at a far lower velocity. So that's probably because of that flow channeling, as I was mentioning, and then because there's a difference in pressure, then you get the flow either side sort of rushing into it. Now these animated streamlines show just how much weight there is down on the bottom half of the trophy. And the globe itself is quite interesting because, as I mentioned earlier, how the flow goes over and then it gets redirected down quite a lot. That's not that common for spheres in general, because generally with spheres, the flow will separate fairly upstream, so like around the edges of it, whereas the flow on this travels a bit further downstream and stays attached longer. The reason for that is probably partly because the bottom half of the sphere is not really spherical, it's actually taken up by this shaft area, but the top part, it's fairly rough, so that means that the flow can turbulate and then it stays attached a bit longer. So those are two potential reasons why that happens. So that's the end of the simulation. Make sure to like, subscribe, and if you want to get better at CFD yourself, check out the courses we do, link in the description, and peace out, amigos.